Right, children. We start with the assignment. Today's first assignment of alcohols, phenols, and ethers. Nomenclature. First compound is CH3 twice C. CH3 twice CHOH. This is the longest chain of 3 carbon atoms. This is 2-propanol, and this is secondary alcohol. Second, vinyl alcohol. This is vinyl alcohol. IUPAC name is ethanol or eth-1-1-ol, and this is allylic alcohol, primary allylic alcohol. Next, CH3 thrice C. OH. This is the longest chain of 3 carbon atoms. This is 2-methyl 2-propanol, and this is tertiary alcohol. Now, fill in the blanks. At the end, we are given normal propyl chloride, and this is prepared by the reaction of D with SOCl2. It means D is 1-propanol, and this 1-propanol is obtained by the reduction of C, because LiAlH4 is reducing agent, and reduction of which compound will give 1-propanol? It may be propanol or propanoic acid. For the time being, answer for C may be propanol or propanoic acid, because both on reduction will give 1-propanol. Now we move backwards. Now this C is obtained by the reaction of B with aqueous NaOH. If C is aldehyde, then B should be dihalide, geminal dihalide. And if it is a carboxylic acid, then it should be a trihalide. So if this is 1,1-dihalopropane, aqueous NaOH will give propanol. If this is 1,1,1-trihalopropane with aqueous NaOH, product will be propanoic acid, and both on reduction will give 1-propanol. Now again we move backwards. This B is obtained by the reaction of A with HBr peroxide. Maximum there can be a triple bond between 2 carbon atoms, 3 bonds between 2 carbon atoms, cannot be 4 bonds between 2 carbon atoms. So this is an alkyne, propyne. Propyne with HBr-OP excess will give 1,1-dibromopropane, cannot give 1,1,1-trihalo. If this is wrong, it means this is wrong. So this is A, B, C, and D. Second sequence, ethyl magnesium bromide chloride with A gives secondary butyl alcohol. A is CH3CHO. If you want, I can explain you. We are given secondary butyl alcohol. This is secondary butyl alcohol. In this product, this carbon which carries OH group, this comes from C double bond O. H will not come from Grignard reagent. H will come from this carbonyl compound. Now we are left with ethyl and methyl group. Ethyl comes from Grignard, which is given. It means methyl comes from carbonyl compound. So this is the answer for A. Now this secondary butyl alcohol is reacted with SOCl2. SOCl2 gives 2-chloropropane, and 2-chloropropane with NaSH, this is NSR, nucleophilic substitution reaction, gives thioalcohol, SH. Third sequence. Now, at the end, we are given tertiary butyl alcohol. This I'll explain. For tertiary butyl alcohol, we are given sulfuric acid and water, and this is E. This reaction is hydration of alkene. With this arrangement of carbon atoms, only one alkene is possible, and that is 2-methylpropene. So E is 2-methylpropene. This is obtained by the reaction of D with alcoholic KOH. There are two answers possible for D. D may be isobutyl halide or maybe tertiabutyl halide. Both will react with alcoholic KOH and give the same product, that is isobutene, that is 2-methylpropene. Now, this D is obtained by the reaction of B with C, and B is obtained by the reaction of A with HBrOP. Now look here. A reacts with HBrOP to give B. It means B is an alkyl halide. An alkyl halide on further reaction gives another alkyl halide. Now think of a reaction in which alkyl halide reacts and gives another alkyl halide. This is Finkelstein's reaction, right? In Finkelstein's reaction, we use Ki in the presence of acetone. So answer for C is Ki acetone, and obviously halogen in this product will be iodine. That will change later. In these reactions, there is no change in number of carbon atoms. There's no change in arrangement of carbon atoms. It means compound A is an alkene with the same arrangement of carbon atoms. It is 2-methylpropene. Now, see, when this reacts with HBrOP, product obtained is isobutyl bromide according to Markovnikov rule. This react with Ki acetone. Finkelstein reaction does not give this, gives this compound. It means D is isobutyl iodide, right? Now, next question. Explain why. All the answers you'll find in notes. Coming to what happens when 1-butene is reacted with diborane and the product is treated with alkaline H2O2. See, in this case, you have to give both the steps. In the first step, 1-butene reacts with diborane to give tributylborane, which on further reaction with alkaline H2O2 gives 1-butanol. And after that, you'll write this reaction is called hydroboration oxidation of alkenes. Second, isopropyl alcohol is treated with iodine in the presence of sodium hydroxide. When so-and-so reacts, this leads to formation of yellow crystalline solid iodoform. You know, 2-propanol has the required group for the preparation of iodoform. You'll write the balance equation as well. Now coming to conversions. First, ethanol into ethane. You can convert ethanol into alkyl halide by any method. Then reduce alkyl halide to alkane. You can use lithium aluminum hydride, zinc HCl, or you can use hydrogen catalyst. One thing is very important. In case you solve a conversion by using a method other than which I'm telling you here, you must click a photo of your answer, share with me so that I can guide you whether your method is right or not. Sometimes you have the feeling the method you're using for conversion is correct, but it is not. So it's better to share with me. Next, propine into 1-propanol. HBr, organic peroxide in excess, anti-Markovnikov addition will lead to the formation of 1,1-dibromopropane. React with aqueous NaOH will give aldehyde. We have used this reaction many times. There will be 2 OH groups on the same carbon, unstable, loses water to give aldehyde. And this aldehyde on reduction will give alcohol. You can use LiLH4. Next, propylene. Propylene is the common name of propene. Propene into normal propyl alcohol. HBr peroxide, anti-Markovnikov addition. After that, you can use aqueous NaOH. You can also carry out this conversion in one step by using hydroboration oxidation reaction. Now, how do we represent that? Above the arrow, you'll write number 1, BH3, number 2, H2O2 oblique OH minus. That is alkaline hydrogen peroxide. Next, propanol into isobutyl alcohol. Remember one thing, whenever you want to prepare an alcohol which contains more carbon atoms than the reactant, then you'll have to, most likely, you'll have to use the reaction between a carbonyl compound and Grignard reagent. That reaction in which I gave you table, that particular reaction has to be used. Now, in this case, product has one carbon atom more than the reactant. Number 2, this product obtained is a primary alcohol. Primary alcohol. And to prepare this primary alcohol, this carbon atom will come from C double bond O. These two hydrogen atoms will not come from Grignard reagent. These two hydrogen atoms will come from carbonyl compound. It means this part, isopropyl part, will come from Grignard reagent. It means we'll have to convert this reactant of 3 carbon atoms into a Grignard reagent of 3 carbon atoms. And after we prepare Grignard reagent, that Grignard will be reacted with HCHO. No, I'll change its position. HCHO will be on the arrow, hydrolysis, and isopropyl Grignard will be reacted with this compound. How to convert this into this? Reduction, LiLH4. We can use dehydration. I'll teach you dehydration today itself. This is concentrated sulfuric acid at 170 degrees centigrade. After this, add NEHX, Markovnikov's rule, Markovnikov addition. Then convert into Grignard, magnesium triether. You'll get Grignard, and react Grignard with formaldehyde. You'll get the final product. Out of 1 propanol and 2 propanol, which is more acidic, and why? 1 propanol is more acidic, and the reason is not that it's a primary alcohol. Primary alcohol is more acidic, definitely. That is the conclusion. But what is the reason? That you have to explain on the basis of stability of alkoxide ion plus I effect of alkyl groups. 7th, name the only primary alcohol which gives positive iodoform test. It is ethanol. Remember, ethanol is the only primary alcohol which responds to iodoform test. Last, give IPAC names of secondary alcohols with the molecular formula C5H11OH. This is like this. In a secondary alcohol, this type of arrangement in any case has to be present with hydrogen on the secondary carbon. After that, we are left with 2 more carbon atoms. I'll write it 3 times. Now, I have to fit in 2 more carbon atoms. One possibility is 1 carbon on the right, second on the left. Second possibility is both carbon atoms either on the right or on the left. That is one and the same thing. This is second answer. Third possibility is I attach both the carbon atoms as methyl groups on either side, 2 methyl groups. It means this is a secondary alcohol, right? So these are 3 answers for this particular question.